Hey guys, welcome to another video from Foolish Engineer. This time we'll check how we can design a voltage regulator with discrete components. There are multiple voltage regulators like 7-8XS series or LDOs present in the market, but our approach will be out of the box. I would like to point out that this design is proven in the industry on rigorous testing, a little bit of experience, small ball of guts, and a lot of fun. So, let's go for a ride. For the circuit, we just need a transistor, to be precise, a BJT or MOSFET. For now, we'll use BJT, a Zener diode, a resistor, and some filter capacitors. We already know that we can use a Zener diode as a voltage regulator. We have seen all about it in this video, but still we'll walk around it to brush up some basics. We can use a Zener diode in forward biased and reverse biased condition. When it is forward biased, it behaves like a normal silicon diode with PN junction, where current flows from anode to cathode. But when it is reverse biased up to its reverse voltage threshold, the Zener diode begins to conduct with the current that flows in the opposite direction, which is called as a Zener breakdown, and this thing doesn't damage the diode at all. If we check the VI characteristics of Zener diode, the point on the horizontal axis, starting from which the voltage on the Zener diode becomes stable, is called as Zener voltage. This Zener voltage value ranges from few volts up to some 100 volts. So, this Zener diode can be used as a voltage regulator by using a resistor in series. But there are some disadvantages of this Zener regulator, such as it has very low efficiency for heavy load currents. If the load current is huge, there will be considerable power loss in the series limiting resistor. If you want to know about the calculation of this Zener regulator, you can check this video, how to select a Zener diode. Second disadvantage is, if there is a change in load current, then current flowing through Zener diode also changes, which result change in output voltage. So this current is limited to only such applications where variations in the load current and input voltage are very small, and we can use this regulator up to few milliamperes only. But to avoid this, we can use the combination of transistor, say BJT, and Zener diode to make a stable voltage regulator. For this, we need one BJT, Zener diode, and a resistor. Now if you compare this diagram with a Zener regulator, we replace the resistor with the transistor, through which the load current will flow, and that's the reason why we call this as a series voltage regulator. Here, if you provide unregulated DC supply through the input terminals, then we can get the regulated DC output voltage across the load, because the Zener diode is providing the reference voltage. The Zener diode provides constant voltage at the base of the transistor. Let's take an example. We want a regulated output voltage of around 6 volts. The input voltage is 7.5 volts and load current requirement is 500 milliamperes. Here we can't use 7806 voltage regulator because the voltage drop across this should be at least 2 volts. So to get 6 volts of output, we at least need 8 volts at the input, and here we don't have that margin because the input voltage is just 7.5 volts. Now for our circuit, if we use a Zener diode having Zener voltage of 6.8 volts, the base voltage of the transistor will remain approximately at 6.8 volts. So the output voltage will be equal to Zener voltage minus base emitter voltage of the transistor, so which will be around 6.1 volts, which is acceptable for my circuit. This resistor helps to limit the current, and it should be selected such that the current flowing through it should be greater than the base current of the transistor. As it is a current control device, selecting an appropriate resistor is very necessary. Well, we need to draw 500 mA of output current from this regulator. And let's consider the HFE of the BJT is 50. Then we can calculate required base current of this transistor from this formula. So the base current would be around 10 mA. Well, this resistor provides the current to both Zener diode and BJT. So the current flowing through this resistor should be the sum of base current and Zener current. From the datasheet of Zener diode, there is minimum current mentioned. Let's say it is 1 mA. So for safe side, we'll consider 10 mA. So required resistance current should be at least 20 mA. Well, the input voltage is 7.5 volts. The Zener voltage is 6.8 volts. Hence the voltage drop across the resistor should be at least 0.7 volts. Now from Ohm's law, we can easily determine the value of the resistor, which will be around 35 ohms. Well, we did the calculation of all components. Now this is the time to calculate the power requirements of these components. This is very easy. So the power distribution can be calculated as the voltage drop across that component and current flowing through it. So the power distribution across Zener diode would be around 138 milliwatts. The power distribution across resistor will be around 15 milliwatts. And finally, the transistor power dissipation will be 750 milliwatts. So we need to select a transistor which will be able to handle 750 milliwatts of power. And finally, we can add some filtering capacitors to this circuit to make it more stable. And this is how we design the voltage regulator. Now, let's see the simulation of the circuit. So this is our circuit diagram. This is the input source. And I have connected a dummy load to simulate the load current. Now we will simulate this. If you check here, we are getting the constant voltage at the output and current is around 500 mA. Now if we change the load resistance, still the voltage stays constant with some change in the current. There are some advantages of the circuit. First, this circuit is very cheap. If we build it, its total cost will be less than an LDO or any voltage regulator IC. We can change the output voltage just by changing the Zener diode and the resistance. The minimum voltage drop across the transistor depends on the collector to emitter voltage drop, which can be less than 1 volts. The power handling of this regulator depends upon the transistor which we are choosing. However, there is a disadvantage of this regulator. The output voltage of the circuit may change due to temperature variation. So, that's all about the voltage regulator. I hope you got something from this. If you haven't, you can watch the video again. Still, if you don't, you can ask your doubts in the comment box below. Hit the like button if you like this video, subscribe to my channel, and finally, thanks for watching.